and my name is Jan Wassenberg. I'm speaking today about CS, computer science research and career. I work at Google. I'm speaking on my own behalf, and opinions are my own. So today I'd like to give some advice, opinion, and facts in various orderings. But let's start with why this might be interesting for you. So you might not always be able to see where you're going. I think the one constant that we can expect is change, that every one of us will have multiple different career switches or changes. And if you can't see where you're going, how can we plan? So I found that the cheapest, least expensive way to learn is from the misadventures of others. I've had a few. And I think it might be a good time to look back 5 years at Google, almost 6, and 10 years after PhD. So it's not so long ago. I don't remember how it was. And what is research? Well, it looks often like we're driving into the fog. We don't know what we're looking for. We don't know how to get there. Often we have to get data to answer these questions. Sometimes we don't even know which questions to ask. So part of writing a paper is figuring out which questions. If you'd like to make a point, the paper might benefit from some data to substantiate that. And basically, if you don't know what you're doing, it is research. So how do I get started on this path, or what am I doing? We've had a variety of topics, most recently image compression, also SIMD or vector programming, doing multiple things at once. Also some low-level things, random generation, cryptography, hashing. A variety of topics. I actually enjoy switching topics every 6 to 12 months. And that may not be your preference, not everyone does that. But what I definitely find motivating is for each of these things, we have the chance to improve upon the state of the art. So it's not just doing the same thing again, it's figuring out some metric and showing a better result. And I find that very motivating. So the early days for me, I started on this really basic computer, TRS-80, hooked up to a TV. It was so limited, you couldn't do much. But I don't want to feed the stereotype you may have heard that you have to be coding from an early age to be effective. I think that's actually wrong and harmful. So if you got started programming in high school or even college, I think that's not too late. It might surprise you, but the reason is that what I did back then, these simple basic programs, it may even be a bad habit. I've heard BASIC, the programming language BASIC, be determined a virus. After that, I did Turbo Pascal, which is similarly obsolete. You may not even have heard of it. So I don't think it's necessary to start at an early age. But neither can we say anyone can program. It does take some practice. What does practice mean? Not just doing the same thing for 10 years. You could say someone has 10 years of experience, or someone has done the same thing for 10 times the first year, and then they did not learn that much. So the key difference is thinking about what we're doing. It's called deliberate practice. So for example, if I'm programming and something went wrong, I realize, oh, last week I did that same mistake. I come to reflect that this is a common problem for me, and next time it might be easier to avoid that pitfall. Another thing I would recommend that's very helpful is not just, grinding against the programming task, but reading books that bottle experience. It's, again, much cheaper to learn that way. I benefited a lot from the book Code Complete. It tells you about the mechanics of programming. There are many other books, and I've read a lot. I can hardly recommend that path. By the way, as we noticed before, in the presentation full screen, I don't see chat questions, unfortunately. If you have any questions, very happy to talk about them at the end. So back to the start. I think that the roof of marketable skills that make people want to hire you And there are probably three very basic pillars of support that most of us might be able to agree on. So number one is it won't always be smooth sailing. There are days when we're debugging or trying to figure out something that's frustrating, frankly. And it takes either passion or at least grit to get through that. So not giving up, persevering, that definitely helps. And it's also helpful not to be in too crowded an area, but still an area that's commercially useful to someone, so someone is willing to pay for it. As an example, ML is very, very, very hot, but it's so active right now, no one can keep up readily with all the papers that are coming out. Finally, having the stamp of approval of a college is something that's definitely helpful searching for a job. It was a bit of a struggle for my parents in Germany, 3 kids through college at the same time. Would not have been possible without some government support, which I gratefully received and gladly repaid afterwards. So financial support for college, it definitely helped. After college, I went on to a PhD, but it's helpful to think first why we're doing this. So for me, the hardest part was the regular ongoing job commitments, delivering value to the company research lab. And then at a certain point, when it comes to a thesis, I had to pretty much disappear in order to focus on writing. And of course, there's a conflict of interest there. And there was also a lot of stress to the point where I lost my voice, could not talk for 3 months. That was very difficult. So getting back to the grit, it really helps if you know why we're doing something. Now, I could tell myself that in college it was a pretty nice environment, interesting tasks, nice people. So you could say, oh, maybe it might be nice to continue here. Or I could tell myself, for many things which I could potentially see myself doing in the future, a PhD can open some doors. So you can see how one of these 2 reasons is much more motivating than the other, and it's really important to know why we're doing something. By the way, as part of that, at Google Research, only about half of the team has a PhD. So depending on the role, it may help or it may at best be neutral. So we've mentioned Google a couple of times. I had actually a rather winding path there. In high school, there was a German federal computer science competition, and I needed a nudge from a high school teacher to join it. I was a little bit shy, maybe you could say afraid. But I did join. The first time I flopped. Second time the next year, did quite a bit better. So the Google recruiters, they somehow looked at the list of finalists and they got in touch, but the timing wasn't right. I just started PhD. The second time I just moved to Singapore, so it was not a good time, but they persisted, and then I went for an interview. And again, the winding road, I failed that first interview, which I think was correct of Google. You could say, oh, maybe it was a false negative. But I think they were right to reject me based on that interview because it's a different job description. For site reliability engineer, that's a different job. I think I'm not as well suited for that. But again, 1 year later, decided to try again, and I practiced whiteboard coding. So usually you have all the support from the editor. When you're writing on paper or whiteboard, it's very different. It's surprisingly an obstacle to solving problems, but preparation helps, and so I passed that interview. Now, what I currently do at work. So you can imagine one, let's say, addition or multiplication at a time, you compute some things, math. Turns out that the CPU is actually capable of doing not 1, but let's say 8 things at a time, except that it's a little bit limited. So I have to figure out how to work on these limitations and also give feedback to the CPU manufacturers and the software toolchain, what works, what doesn't. And the main application for that right now for us is an image compression. My job was to make it fast. You can't wait for the browser to download images. You want it to be decoding quickly. And also some parts of the codec, for example, smoothing to get rid of artifacts, or you could say noise or blockiness. Finally, we're getting into the browsers now, Chrome, for example, so deployment, productization, making it work under all these obscure circumstances, that's ongoing work. And finally, maybe surprisingly, because we've been talking about research, only occasionally do we publish. For us, it's not a focus, but for other teams at Google, it's much more important. So the image compression I was mentioning, that has turned into JPEG XL. It's an ISO standard. We've engineered it from the ground up to replace the existing image formats. You might know JPEG, PNG, even GIF is still around for little animations. So we have all the features you might expect that JPEG had, and then more. HDR, also lossless, transparency, high bit depth, wide gamut, all the modern goodies. Maybe also most interesting for practical use is that you can do progression, which means that if you're on a train, if you're in a tunnel, the connection drops, you've only got half of the file, you can actually see something already. And the encoder, you can just let it loose on all your pictures and it will encode them without you having to inspect each one. So it's designed to keep really a lot of the texture and detail. You don't have to specify all these magic parameters per image or look at the results. Finally, the speed aspect I was mentioning. So we have to run on desktops, of course, but also mobile. So again, it has to be very efficient, and we didn't or wouldn't rely on custom hardware to save us. So you might imagine that computers keep getting faster, but there are limits to that. You can always spend more time than you've got. We have to guard against that. And the challenge is we have this interesting new codec. So we'd like to get it in browsers, adopted various other places. But how do we convince people if we don't even agree on the metric that will guide that decision? Also, if we're talking with people at Google and beyond, I often hear that there's so many more things to do and time to do it. So prioritizing and agreeing on the prioritization, that's tough. Another interesting issue is that as a research team, once we've done these, once we have good, let's say, outcomes or results, then getting that productionized or getting that actually useful for the real world, you can call that cost of success versus putting the effort into doing new, interesting things. So these challenges, the interesting thing about them is that they're all non-technical, all people issues. So that is a surprise for me, and I didn't learn about any of that in college. Also, the development process for software. Sometimes I feel like this baby here at the wheel. We're developing in C++. There's infrastructure that's almost like science fiction. It's a very nice safety net. And how we actually develop it depends. Some circumstances you might have a high trust circumstance and you can rapidly prototype, just do experiments, throw away the results. That's important. Sometimes you have less knowledge or experience with some of the people, so you have to have a more deliberate process where you do a design document, you do discussions with various stakeholders and code reviews at every point. So that's the slower process. And both of those are actively used. And again, I didn't learn any of that in college. If you have, then you're ahead of the game, good for you. But there's something I wish I might have learned earlier. Okay, so that has been my path. Now I have some more opinions. Everything is opinion, but this might be termed advice, which you might find interesting. So I have seen various points on the spectrum of academia to corporate. And the first one at college, I've seen that the PI or the prof has to worry about funding. Once that funding is secured, you can work fairly freely. There's young students You could say a vibrant community. There's teaching involved. For some that might be good, some not so good. I did my PhD at an applied research lab, Fraunhofer, for anyone who knows it. And they have an interesting model. They get some basic funding from the state, so they can do some basic research, but they're required to actually get some of their funding from companies. So that forces them, or makes sure that they do something that the company is willing to pay for. Then I was in Singapore working for Black Magic Design, you could say small, medium business. The name sounds scary, except they do cameras and video editing, post-processing for Hollywood. James Cameron's a particular fan. So that was very strongly driven by the yearly trade show, the NAB. So we had to make sure we meet that deadline. It is very, very firm. The good thing is that you see directly your customers. That's motivating. You see what their experience is. That's helpful. And finally, I've been at a corporate research lab. Google is one. Microsoft has similar environment. And you can say that the product and the research teams, they actually have strong links. Sometimes the line between them is quite blurred. And the really nice thing is that we can have very large impact. So the JPEG XL, if it is adopted in Chrome, it can instantly roll out to 1 billion people, which is a unique opportunity, I think. Further things I appreciate is that we're actually able to do open source, so everyone benefits from that. And the areas I find interesting, there's some freedom to choose which area you work in as well. Maybe most of all, the people I work with are extremely sharp and often very, very helpful. That is often described as a big perk. And the infrastructure I mentioned. The safety net is good. I actually broke Google on one occasion, but it was very quickly found and fixed. So yes, good safety net. Humans are fallible. Now, I was mentioning career at the beginning. Career, hopefully you go upwards, but again, the path is not always clear. The path might be very winding. I learned a couple of things on the slide, and it generally was pretty expensive. So if nothing else in this talk, if one or even two of these things resonate with you and save you from mishaps, I think it will have been worth it for everyone. So let's go through it top to bottom. And you may have heard of growth mindset. And there's a distinction between that and fixed mindset. So growth mindset is you think that you can improve with effort. Fixed means you think that you're born with something and you can't overcome that. So it turns out that growth mindset, people with that focus, I say not born with it, but current focus, and they tend to work hard at problems and give up later. And I think that is really, really important. You can improve. The key point is you can improve whatever you set your mind toward with practice and effort. And again, if you don't believe that, there's a book that tells you about it. You can change this way of thinking. So growth mindset, very important. Maybe the most important thing here is a people issue, though. So at various points, we've been chasing deadlines, crunch time. We did what it took to get the project to where it needed to be. But the project will come and go. The people, you'll meet them again at some point, and they will remember how they felt. And I think it's very important to keep the long term in mind. So I've learned that we should prioritize the working relationships, not just do the most expedient thing for the short-term success. And one simple and obvious thing is that sharing credit is actually quite important. People do notice if you're the kind who generously shares credit. And I think it's actually even multiplicative. So it's not that, oh, I have this paper, I have 4 others, so I have only a quarter of the credit. I think that in many fields, it's increasingly uncommon to see single author papers. And it might even have the implication that, oh, it must have been a relatively small task. So being generous with the credit and co-authors, even recruiting co-authors, I think can lead to more effective collaboration. And for collaboration also, whether or not it's formal authority or just informal, people tend to be motivated by autonomy, mastery, purpose. There's an entire book about this, Drive by Dan Pink. In short, the negation of what we want is if people have no autonomy, they're micromanaged, and it does not lead to mastery, so it's the same drudge work, no improvement in mind, and it doesn't tie into any of their deep values, so it's not meaningful or purposeful to them, then they are totally disengaged. So that's absolutely not what we want. Autonomy, mastery, purpose. And if we can arrange that, then motivation goes up and results go up. If we find ourselves arguing in circles, intractable discussions, I found that it's not that it's the topic, it's that the people have a different view of this topic and different underlying values. Someone might prioritize delivering, someone might prioritize doing it at the utmost quality, and you can't convince each other without going into those values, without really shining the light on why is it so important that we deliver, or why is it so important that we have high quality. Without addressing that, we will tend to keep going in circles. And when we start a new project, I found two different ways of going about it. They are pretty much opposites. Number one, which I personally prefer, is we can start out by reading the state of the art, digging into papers and citations of those papers. And then we have a pretty good overview of what has already been done, and that might jog some ideas. We might have, we might see the next thing that we can improve. The other thing I've seen work is if we deliberately do not look at the state of the art and think from first principles what can or should be done, which might sound silly, deliberately ignoring, but the reality is many decisions are made with assumptions such as CPUs have this and this attribute, or they only have a single thread or core. So many of the things that were ignored, rightfully so, in the past turn out to be different or have different optima today. So reasoning from first principles and deliberately ignoring can also work, but it's a little bit risky. You may have found it cheaper to just read up on the papers. And finally, one very general point is that we might, and I personally at various points have believed, oh, I have this difficult project now, but once it's done, or once I finish the paper, or once I'm accepted into PhD, or I finish my PhD, then I will be happy. But the sad reality is that, you hear from this list, there are all these various hurdles, and as soon as you reach one, you will see the next one in the not so far distance. So making our happiness conditional on these things just means that we're never happy. We will never have reached all of the hurdles. Now, on the contrary, I notice that when I'm centered, that is, I do the things that I need to keep me functional, which includes exercise, seeing people, which is difficult nowadays. But this kind of things, which you could call a happiness, they tend to increase success rather than the success leading to happiness. And that is maybe a tough principle to digest in just one paragraph, but it's something to keep in mind. So I would heartily recommend mentoring. I personally have benefited a lot from various mentors over the years, some from carpooling, some from structured work environments. And I myself am mentoring some engineers, and I've seen some, I would call successful people who think, oh, this is called imposter syndrome. Not sure you're familiar with it, but these people believe, oh, everyone else is so smart, I have all these limitations. It turns out that these very capable people are afraid that they're not good enough. So someone else with a neutral perspective can help to lift that fear and realize, hey, you're doing fine. Everyone has strong suits and weaknesses, things they're working on. How do you find such a mentor? Well, the first thing is that there's probably not going to be one person who can cover any and all topics that you'd like to have covered. Maybe your organization has a formal process. I'd go for that. It's quite easy. Sometimes you just have to ask people. If you don't ask, you're guaranteed not to have a yes answer. When you ask, though, if you're going to ask, let's say, the CEO, it's not likely to succeed. So if you have someone you're looking up to, you'd like to ask them, but they're so far out of reach. Maybe it's been so long since they were in your shoes that they don't even remember how it was. So it can help to look some stepping stones. What are people with similar attributes that you admire, but a little bit closer to your current circumstances? Maybe reaching out to those people is more effective. And very interesting question, probably helpful for success, is answering explicitly or implicitly to them why they should help out, why it would be worth it for them. Speaking for myself, sometimes mentoring can help me understand myself better as I explain things to someone else.